All right, guys, welcome to our Unit 6, Quiz 1 study guide. I'll be doing the even ones. Those are the ones that you're required to do. If you want to do the odd ones, you can, and the answers are included for you to check your progress. So let's go ahead and begin here. So for number 2, it says factor out the common factor, and that means all you need to do is look for a GCF here. So what goes into 63, 45, and 9? The biggest thing would be 9. And we can also take out n squared because they all have at least 2 n's to offer. And so if we divide 63 by 9, we end up with 7. And it has 2 n's, and if I take 2 n's out of it, there's no n's left. Next, 45 divided by 9 leaves 5. And if I take 2 n's away from that, I'm left with 1 n. And then finally, 9 divided by 9 leaves 1. If I take 2 n's away from that, I'm left with 4. And we could stop. Sometimes you might need to go further, right? We might have to do a box on this, but I'm not going to. And the reason I'm not going to is because it's only asking me to take out a common factor on that one. So that's it for that one. Let's go ahead and move on to number 4. All right. For this one, we want to factor it. You always start by looking for a GCF. Now, just so you guys know, on the first few problems after the initial one we just did, I'm not going to have GCFs on these, but it's always good to look for it. So in this case, I can't take any m's out because there's no m in common. Also, I can't take any coefficients out because there are coefficients of 1 here, and if that's the case, you can't take anything out. So we can skip the GCF step for now. But we are ready for the box method here. Whenever you have 3 terms, the way we do is with the box method. You put the first term in the top left box, you put the last term in the bottom right box, and the goal is to find the numbers that will correctly give us the outcome. So what times what makes m squared? Well, that would be m and m. And what times what makes negative 30? That would be 6 and 5. And it could also be 3 and 10 or 30 and 1 maybe, but you have to, it's only going to be one of them. You have to figure out which one actually works. Notice also it's negative 30, so one of these has to be 30. So I'm going to go ahead and make this the negative and this is positive. And what we do is we fill in the box to see if we got it right. So here is 6 times m, which is 6m. And then here is negative 5 times m, which is negative 5m. And we know we're right if these 2 terms here add up to make the middle number, which they do. 6 minus 5 is 1. So we've done it correctly. And my answer is this guy and this guy. And remember, if you don't get it on your first guess, all you have to do is maybe try swapping the numbers around or trying some different numbers. But that's basically the strategy. Let's go ahead and take a look at another one here, number 6. So once again, you start by looking for a GCF, but there's not going to be one on this one. So I'm going to move on. And it's got 3 terms. We do the box method. First term goes here. Last term goes here. And we're going to split it up. Now the first one here is easy to find because we know the x squared has to be split up evenly into 2 x's. And there's only one way to get 7, so it has to be 7 and 1. Now that one, we have a lot of possibilities. But that 72 down there, there's a lot of ways to make 72. Let's go ahead and try 9 and 8 first. 9 times 8. It could also be 12 and 6. It could be 36 and 2. There's a lot of possibilities. But I like to start off with the most moderate looking numbers, less extreme numbers. So let's go ahead and see. Now it's a positive 72. So 7 times 9 is 63x. 8 times 1 is 8x. And these two need to combine together to make this. Now they almost do, but notice that 8 and 63, they make a positive 71. I want a negative 71. When you get the right number but the wrong sign, it's an easy fix. Just make these 2 numbers an opposite sign from what they were and you'll have it. So once again, I got it lucky on my first draw there, and there it is. All right. move on to number 8. Got another one. Once again, no GCF, just more straight up box practice here. So I like to include a lot of these ones just because they are challenging. The more practice, the better. All right, so what makes 9k squared? Well, it could be 3k times 3k. And what makes negative 9? Now, I don't know if I'm going to get this one right. So maybe if you're copying me, don't write it until you see me get it correct at the end, because I might not be right on this one. Down here I've got negative 9, so that could, now a little hint for you. Negative 9, although this number could be made by negative 3 and 3, I know that's not the option. And the reason for that is because if I were to put 3 and 3 here, these have a common factor and they shouldn't. If there were no common factors up here, then we shouldn't have any common factors here. So I already know it's not going to be 3 and 3. That's a little trick to save you some time. So I'm just going to go ahead and try 9 and 1. So let's see how that works out for us. Now one of them has to be negative. I'll just make it the 1. Filling in my box, I get 27k, and then negative 3k. Now you'll notice that's nowhere near correct because 27 minus 3 is 24, and we need negative 80. I need a really big number. So that didn't do us any good. So what can we do now? Well, let's start over. I already knew it couldn't have been 3 and 3 on the sides there, so it had to be 9 and 1. And I couldn't really swap them either because the 3k's were the same anyway. So how about instead of 3k on each side, we try 9k here and 1k here. Let's see how that works out for us. That gives me 81k, and that gives me negative 1k. All right, we're close. That's a positive. If I were to add these together, I get positive 80, but I need negative 80. So, but that's an easy fix, right? When you have the right numbers but wrong sign, all you have to do is change this sign and change that sign, and that will get us the correct result. So the answer there is 9k plus 1 times k minus 9. So if you didn't write this down yet, that's the one you want to write down. But it's very much a system of just trial and error. All right, let's go ahead and move on to number 10 here. Now, when you see it say factor completely on my little worksheets that I give you, that basically means that, okay, we might have to do more than one thing here. But I don't know, this doesn't look like it has a GCF to me still. So I think it's still just a box problem. I still don't see a GCF. I thought when I saw this instruction it might have like a GCF in there also, but it doesn't seem to. Let's go ahead and get to work here. So we have 9m squared here and negative 18 here. And let's try the less extreme numbers first, 3m and 3m. And what makes 18? Okay, well, I already think I'm wrong on my first guess. And the reason I think that is because no matter how you try to break up 18, whether you choose to do 18 and 1, these have a common factor, which we know is not allowed from the last example I did. Or if we do 3 and 6, now both of these have common factors, which I said is not allowed. So the other option would be 9 and 2, in which case we end up with a common factor here. So that means I'm going to actually back up a little bit, and I'm not going to do 3m and 3m. I'm going to do 9m and 1m. All right. Now, I have to break apart the 18, and when I do that, I have to make sure that it's in such a way that we don't get any numbers that would have a common factor with 9. So there's a couple ways to make 18, which we already talked about. 1 and 18, 2 and 9, or 3 and 6. I know it can't be 3 and 6 because whether I put the 3 here or the 6 here, it's going to have something in common with this 9, which isn't allowed. So I'll just get rid of that. But we could start with 2 and 9. So I'm going to put the 2 down here with the 9. That way they don't have any common factors. And then the 9 I'll put up here. So let's see how this works out. 9 and 9 makes 81. Ugh, that's going to be way too big. And then 2 and 1 makes 2m. So that's no bueno. Oh wait, or maybe it is actually. Let's see. Oh yeah, one of these were supposed to be negative. So I'll make this one the negative. Let's see. So negative 2 and positive 81 does make 78. All right, cool. I just wasn't expecting such a big number in the middle there. But there it is. So I got lucky there on that one. But as you guys can see, this trick about recognizing you can't have common factors here or here is a great way to rule out possibilities without having to go all the way through just to be disappointed. So if you can already rule out some possibilities, that can narrow your guesses that you have to make. All right, let's go ahead and take a look at number 11. Now, number 11 is well, actually, we're not doing odds, are we? Do number 12. Number 12, this is our first problem where you're going to actually have a GCF. There is something that goes into all 3 of these. So I'm going to take out a 3 here. After that, we look at this piece, and we're going to do the box method on it. M times n makes m squared. For 15, we need 5 and 3. One is going to be positive, one's negative. We want to make sure that once we're done filling in our box, that these 2 terms add up to make the middle, which they do. So I've got 3 in the front from my GCF, and then the trinomial broke apart into these 2 things here. And that would be the end of that one. Let's go ahead and take a look at the next one, number 14. These are awesome. These are what's known as a difference of squares. Notice there's no GCF here, so we could skip the GCF step. But when you have 2 numbers that have perfect square roots, like you could take the square root of x squared and get x, and you could take the square root of 16 and get 4. So when you have 2 perfect square roots with a minus in between them, you're going to write those 2 square roots twice, once with a plus and once with a minus. Those ones are nice to factor. And we're done with that one. All right, let's take a look at this one. This is a 4-termed polynomial. I'm wondering if there's any GCFs on there. I know that only 3 and 5 go into 15, and none of those, you can't divide 3 out of 20, and you can't divide 5 out of this, so I don't think there's any GCF on this one. So we could skip the GCF again, and we're going to move right into the box method. You do the same thing with the 4 terms as you do with the 3 terms. You're going to put the first term in the top left, last term in the bottom right, and then you go ahead and start putting the other 2 in there. That's where it's a little bit different, is you don't have to guess what these are. You know what they are. And when you have all 4, all you have to do is factor out what they have in common. So for instance, to find out what this number is, I just need to find out what these 2 numbers have in common. Both 20 and 15 can be divided by 5, and also they have at least 2 x's. So we could take out an x squared. To find out what goes here, we find out what these have in common. Looks like both of those could be divided by 8. Can't take any x's out though. To find out what goes here, we look to see what these have in common. I'm going to go with 4 on that one, as well as an x. And then for these 2, that will give us this last blank up top there. So I think both of those can be divided by 3. Now, we have a little bit of an issue here, you may notice. I've got some negatives here, but I don't have any negatives in my answer outside yet. When that happens, both of these are negative here, because a negative 8 times a negative 3 will still give us a positive 24 here, but it will make both of these negative so that we get the correct outcome there. So we have 5x squared minus 8 times 4x minus 3. And that would be the final answer there. Or is it? You really should check to see. Once you do that, we only have binomials, and the only thing that those could be after that is a difference of squares, but they're not. Neither one of these are a difference of squares, so we are done with that one. Let's do another one like that. Do we have any GCFs? I think all of those can be divided by 5, so we'll take out a 5 here. So this one does have a GCF. Next, we're going to go ahead and do our box method here. And here, we find the common factor of these two, which is going to be 1v squared. The common factor for these two is going to be 4. The common factor for these two is going to be 5v. The common factor for those two is going to be 4. And once again, when you have two negatives here and a positive here, that means both of these things here and here are both negatives. So I've got a 5 from my GCF. And then from the box, I get v squared minus 4 and also 5v minus 4. Now, this is done, and this is done, but this one's not. That's a difference of squares, so we can keep going there. So this thing can split apart into two more things. You take the square root of v squared. You take the square root of 4. You make one a plus and one a minus. And now both of these are done because neither one of them are differences of squares anymore. And we have our final answer. All right, let's move on to our next one. So we're transitioning now away from factoring and getting into multiplication. It's the opposite of factoring. So instead of starting inside the box, we start outside the box. So we put 7r minus 2 and 3r plus 1. And we fill in the box with multiplication. So 3r times 7r is 21r squared. 3r times negative 2 is negative 6r. 1 times 7 is 7r. And then finally 1 times 2, negative 2 is negative 2. So we have 21r squared. And then we have these two that we can combine together. 7 minus 6 is positive 1r. And then we have our minus 2 at the end. Final answer there. So we've got a 3 by 2. When you have that, you're going to need to make a longer box to accommodate the 2n squared plus n minus 6. Other than that, it's pretty much the same. So 5n times 2n squared is 10n cubed. 5n times n is 5n squared. 5n times negative 6 is going to be negative 30n. 5 times 2n squared is going to be 10n squared. 5 times n is going to be 5n. And 5 times negative 6 is negative 30. And we can go ahead and start pulling out our terms. So in the top left box, we have 10n cubed. Then we have these two terms, which are like terms. 10 plus 5 makes 15n squared. And then we have these two like terms. Negative 30 and positive 5 makes negative 25n. And then finally, we have the negative 30 in the bottom right corner there. So there's our final answer on that guy. Let's move on to 24. Got a 3 by 3 here. So we need a box that's 3 by 3 in size. Put one of your trinomials along the top, one of your trinomials down the side, and fill in the box. So 3m squared times 4m squared is 12m to the fourth. 3m squared times 8n is 24m cubed. 3m squared by 8 is 24m squared. Negative 7m times 4m is negative 28m cubed. Negative 7m times 8m is negative 56m squared. Negative 7m times 8 is negative 56m. And we have negative 3 times 4m squared, which is negative 12m squared. Negative 3 times 8 is negative 24m. And then finally, negative 3 and positive 8 multiplied together makes negative 24. So we're ready to write our final answer here. Here's my first term, 12m to the fourth. Next, we have some m cubes here. We can put those together. Negative 28 and positive 24. If you add those together, you end up with negative 4m cubed. We have 3m squareds here. That's quite a bit. Gosh. Let me see if I can figure that out real quick. So if you add together 24, negative 56, and negative 12, you're going to get negative 44m squared. Next we have our m's. Putting those two together, another big number pair. So it's going to be, I think, negative 80m. You put the negative 56 with the negative 24. And then finally we have the negative 24 at the end there. And there we have it. Go ahead and take a look at number 26. Now this is a difference of squares. Now you can do a box if you want to. It will work. But I'm not going to do the box method. I'm going to do a different way. This is a difference of squares outcome here. When you have the same thing twice, but one's positive, one's negative, all you have to do is do the first number times the first number, and the last number times the last number. And you're done. So that's the answer there. So I prefer to go with a shortcut when I can. That's one of the shortcuts that we learned. Another shortcut we learned is these kinds. So when you have a binomial being squared, that means you're multiplying a binomial by itself. And when you multiply a binomial by itself, there's another kind of shortcut. Once again, you could do the box for this if you want to, but I'm going to use my shortcut. The shortcut is 5 times 5, and the two last terms multiply together. Negative 3k times negative 3k is positive 9k squared. And then finally, we need a middle number here. You multiply these together, so negative 3k times 5 is negative 15k, and then you double it. So that will be negative 30k. A little bit faster than the box method. Shortcuts are nice. But the box method would work if you can't remember the shortcut. All right, now we're going to get into some polynomial long division. So let's go ahead and take a look at number 30 here. So when you're doing polynomial long division, the first term, or the first polynomial, goes under the bracket. You want to make sure that every term is present. In other words, we're starting with a fourth power. After that, we should have a third power. And after that, we should have a second, and so on. We shouldn't be missing any powers. And we have them all there. It goes 4, 3, 2, 1, none. So this one goes on the outside, and the same thing goes for that. You don't want to have any missing powers. And how long division works is you just ask yourself, what would I multiply this by to get this? And the answer is 5x. And then you would multiply that 5x by all 4 of these and put your answer here. So 5x times x cubed is going to be 5x to the fourth. 5x times x squared is going to be 5x squared. 5x times x is going to be, 5x cubed, my bad. 5x times x is going to be 5x squared. And then 5x times negative 4 is going to be negative 20x. And then we go through and subtract all these, or change their signs, in other words. And then we add down. So these cancel. These combine to make negative 2x cubed. These combine to make another negative 2x, but this time it's squared. And these combine to make another negative 2x, and then we bring down the 7. All right. We repeat the process now, but this time I ask myself, what would I multiply this by to get this? And the answer to that question is negative 2. And once again, you're going to multiply that negative 2 by all 4 of these and put your answer here. So if I do that, I get the following. And once again, you go through and subtract everything, which causes all their signs to change. And you combine downwards. And everything cancels out there, and all I'm left with is negative 8 and 7, which is negative 1. So now we're done. As soon as the polynomial down here has a power that's less than this, which is the case because I don't even have an x anymore now, you're done. And so this thing on the top here is your quotient. And then you put your remainder over your divisor. And that's the final answer there. So we have another long division problem here. It's kind of repetitive. Let's see here. But I guess we'll go ahead and do it anyway. It would have been nice if one of these had a missing power, but once again, there's no missing powers here. They're all there. It goes 3, 2, 1, none. Same thing here, 2, 1. But remember, if you ever do have a missing power there, you have to put a 0 in its place as a placeholder. Anyway, let's go ahead and I'll just work my way through this one. Now, I explained how to do these on the last one. So on this one, I'm just going to kind of quietly work through it, but you guys can watch me go through it just to kind of check your work. All right, so there's number 32. Go ahead and take a look at number 34. Now, for these ones, notice that anytime you have a binomial here, we're going to use something known as synthetic division. It's much faster, and you could do long division, it'll work, but synthetic division is just much faster. And here's how synthetic division works. Once again, you can't have any missing terms. It has to go from 3 to 2 to 1, and that's it. You can't have any missing terms, so we're good there. But what we do is we put the coefficients in the box here at the top. So it's going to be 3, negative 17, negative 12, and 30. We don't really care about the x's. Next, we're going to put this number in the front, but the opposite sign of it. So instead of a negative 6, I'll put it. So after that, we're going to go through a repetitive process here. The first thing we're going to do is bring this 3 down. We're going to multiply the 6 by the 3. And then we add these together. And repeat. 6 times 1 is 6. Add these together, you get negative 6. Multiply these together, you get negative 36. Add these together, you get negative 6. And there it is. Now this number is my remainder. This is my constant. This is my x term, and this is my x squared term. So the answer is going to be 3x squared plus 1x minus 6 plus my remainder all over the divisor. And there's that. Do one more of these, and we'll call it a day. All right, so this is an example of one in which we are missing something, right? The first one we had like that. We go from an x squared to a 3, and that shouldn't be the case. So we want to put a 0 placeholder in there with an x, because it should go from 2 to 1 and then the constant. If you don't do that, you will end up getting a wrong answer, so you want to make sure you do your placeholders. That same process is required for both long division and for synthetic division. So, to continue, the process on 36 after this is basically the same thing we did in 34. So we have 9, 0, and 3 here, and a negative 1 here. Bring down your 9, multiply the 9 and the negative 1, add down, multiply 9 and negative 1 to get 9, and add those together to get 12. This is my remainder. This is my constant, and this is an x. So the final answer is 9x minus 9 plus a remainder of 12 over x plus 1. And there's our final answer there. And that does it for review, so hopefully that was helpful, and we'll see you guys in class.